Hello everyone, we'll continue our discussion on pressure. And this already we have seen that atmospheric pressure gets calculated to a value of 101.4 kilonewton per meter square. Here gamma m, how to calculate this gamma m? By the definition of specific gravity. So specific gravity is a ratio of specific weight of a material, in this case specific weight of mercury, divided by specific weight of water. If you rearrange the terms, gamma m becomes specific gravity of mercury multiplied by gamma w. That's what is done over here. We all know that specific gravity of mercury is 13.6, and specific weight of water is 9.81 kilonewton per meter cube. That's how this whole expression becomes gamma m multiplied by h, which is 0.76 meters. So overall it gives you atmospheric pressure as 101.4 kilopascals. Right, slight variation in this number would be there, but you can always take it as 101.4 or 101.3 kilopascals, kilonewton per meter square. We'll go further. Okay, this is atmospheric pressure again, once again. So here there is a picture of a balloon. Now if you talk about pressure outside, it is atmospheric pressure, but this pressure, the pressure with which you have blown it, right, is higher pressure. So there is larger pressure inside which is trying to push the membrane out, and there is atmospheric pressure outside. Okay, then there's one more case here. Already you have seen this container. Here what has happened is, in the beginning the pressure outside and pressure inside the bottle is same, but if you remove the air, if you suck out the air by some means, the external atmospheric pressure will be trying to squeeze it, right? That is what is shown here. So atmospheric pressure will be coming into picture only when you try to vacate this, or you try to vacuum it, right? So remember those instances. Okay, here I'll be introducing a new concept, pressure measurement types. This already we have seen in earlier video, that the fluid pressure always perpendicular to the surface of contact. Fluid pressure always acts or will be there perpendicular to the surface of contact. I have discussed in length about vertical phase, horizontal phase, even inclined phase can be similarly. That is, it has to be, the pressure acting has to be perpendicular to the surface that is in contact. Okay, anyway, we'll go further. The types of measurement, I will read it here. Pressure in fluid medium is measured in two different systems. There are two ways how the pressure can be given. They are absolute pressure and gauge pressure. So what are the two ways how pressure can be given? One is absolute pressure, it will be mentioned. Another one is gauge pressure, right? Whenever pressure is mentioned, generally you have to say that it is a gauge or absolute. So types of pressure or systems of pressure, absolute pressure and then gauge pressure. There are two ways how we can measure. Now what is actually meaning of absolute pressure, and then what is meaning of gauge pressure, we'll see here as a statement, and then in next slide we'll go into the details of that. Okay, here if I read absolute pressure, it is measured with respect to complete vacuum or absolute zero. No pressure exists below this absolute zero. What it means is, if you have a container like in earlier slide we have a container, and then there is air present in this. Now if you take out a little amount of air, right, if you suck out air, what happens is this crushes. Now if you go on taking out the air, and if you completely vacate, means that there is no air left, then inside that it is known as absolute vacuum, or there is nothing inside, right? And even then if you try to suck out something, right, what you will be able to suck, there is nothing. Because of that, the pressure will not decrease below the absolute vacuum. That is what one should know. So that's why uh, no pressure exists below this absolute zero. So you cannot go below absolute zero or absolute vacuum. Okay, what is gauge pressure? Now this is the pressure measured with respect to atmospheric pressure. Means normal pressure that is felt by human beings is absolute atmospheric pressure. If there is a pressure higher than that, then only there will be a feeling, right? Otherwise you don't feel. Also, if there is a lesser pressure, then also one can feel. That's why with respect to atmospheric pressure also we can measure or sense the pressures, and that is known as gauge pressure. Hence gauge pressure can be above or below atmospheric pressure, and accordingly it is referred to as positive. Means if the pressure is more than atmospheric pressure, it will be referred to as positive pressure, and if it is below generally negative, so it is negative pressure. Negative pressure is also known as vacuum pressure, right? Okay. Okay, we'll go to the next slide so that we'll have a lot of details. Pressure measurement types, absolute pressure and vacuum pressure. That's what I'm going to discuss here. Here it's a graph. I mean, this you have to keep it in mind that it is a graph, not actual situation. It's not a picture of actual situation. So it is nothing but a graph where this level is atmospheric pressure. So this is a graph. At this particular level I have shown atmospheric pressure. The pressure above this is upper pressure or higher pressure. The pressure below is lesser pressure. We'll consider a couple of points of references. One pressure point B, another pressure point A. I can take at any point here. Here also B can be taken here up to this particular point. Okay, points of reference, right? Not in space, it is a graph. I am telling you often. Take care. Now here this particular pressure at A is above atmospheric pressure so much. This is atmospheric pressure. So this particular pressure at point A, I am trying to show that it is above atmospheric pressure and so much. So pressure level above atmospheric pressure, that is what it is. I don't know whether it's okay or not, but at this particular point, one more point if I try to make and then call it as C. So pressure at point level C is atmospheric pressure, and then if you go at higher level, the pressure will be higher and higher. So such a point A is how much high? So much of pressure, it is higher than atmospheric pressure. That's what it is, pressure level above atmospheric pressure. Now this particular point P is below atmospheric pressure by so much. So pressure level below atmospheric pressure, so much of magnitude. Okay, now if you go on decreasing as just now told, right, you can vacate the container. Means from the container if you go on removing the air present, so what happens is it becomes completely vacuum. At that stage, we call it as complete vacuum or absolute zero, right? There is nothing, means you cannot make the pressure still less. That is the thing, complete vacuum, right? Now there is one more way of measuring the pressure. So here what is done is the pressure at A and B with respect to atmospheric pressure, how high it is, how low it is with respect to atmospheric pressure, we have seen. But the same point subpressure, level subpressure, can be said with respect to complete vacuum, how much is the pressure. Even point B with respect to complete vacuum, how much is the pressure. So reference is complete vacuum or absolute vacuum. So this way also pressure can be measured, and such a pressure is known as absolute pressure. So pressure at A and B are measured with respect to complete vacuum and known as absolute pressure. So here the measurement is done from here to there, and then for B also from the same level complete vacuum, and then afterwards it will be measured. The another way of measurement is atmospheric pressure. From atmospheric pressure, how much high or how much low. So pressure at A and B are measured with respect to atmospheric pressure, and it is known as gauge pressure. Okay. With an example, we'll see further. Okay, here a similar diagram I have drawn. Here, this is the level of absolute zero or absolute vacuum. Again, similar points, point A and point B are there. Right? If you measure with respect to atmospheric pressure up or down, so pressure at A will be known as gauge pressure, pressure at B will be also known as gauge pressure. Now the same pressures, if you refer with respect to absolute zero, they are known as absolute pressure, pressure at A absolute, pressure at B absolute. But because there is an atmospheric pressure involved, we can relate these two. For example, this absolute pressure will be written as atmospheric pressure plus gauge pressure. So that's what I have written here. Absolute pressure is equal to atmospheric pressure plus gauge pressure. We know that atmospheric pressure magnitude is 101.325 or 101.4 kilopascals. So if I want to find out gauge pressure, right, I can calculate always by subtracting atmospheric pressure from absolute pressure, right? Okay, now I have considered a point uh, pressure at point A as gauge pressure of 20 kilopascals. Let us say this is 20 kilopascals above atmospheric pressure. Now can I calculate absolute pressure? Obviously P absolute will be equal to atmospheric pressure plus gauge pressure. So this is 101.3 plus I have a value for this as, let me write it as just 101 or 101.3. Now this plus this becomes 121. So 121.3 units are kilopascals. One should not forget to write kilopascals and mention that it is absolute pressure. So that is what it is. Now let us say, so here gauge pressure was given, we have calculated absolute pressure. Now let us say pressure at B absolute is equal to 70 kilonewton per meter square. Means with respect to this level, the pressure over here is this particular pressure is given to be 70 kilonewton per meter square. Now can I calculate gauge pressure for this? I'll use the same formula. Gauge pressure will be equal to, look at this, gauge pressure will be equal to absolute pressure minus atmospheric pressure. So 70 sorry, 70 minus 101.325. So this becomes negative. So minus 31.325. That's why this pressure, which is below atmospheric pressure, will be referred to as a negative pressure or simply just vacuum pressure. Vacuum pressure does not mean that it is a complete vacuum, but some part of the air or content has been removed and then it is under uh, atmospheric pressure, which it is below atmospheric pressure. That's why it is called as negative pressure or vacuum pressure. So note that point B is below atmospheric pressure. That's why it is referred to that way. So as far as absolute pressures are concerned, they will never be negative. That is what one can remember. So I repeat the sentence: absolute pressures will never be negative because the reference is absolute zero. You don't have a pressure below this, right? So because of that, you cannot have absolute pressure negative. But as far as gauge pressures are concerned, because the reference is atmospheric pressure, it can be more or it can be less than atmospheric pressure. So whenever pressure becomes less than atmospheric pressure, we call it as vacuum pressure or negative pressure. Okay. See, the atmospheric pressure will be crushing the things when you vacate or vacuum the container. That is what is shown here. Okay, thank you. There will stop.